Welcome to this screencast of 6.6, Rational Exponents. So we briefly covered this in 6.4 and 6.5. I already told you the secret of rational exponents. But let's go ahead, let's talk about it. So if I had a cube root of x, I could rewrite this as x to the third. If I had a fourth root of x, I could rewrite that as x to the fourth. So if I had a fourth root of x, I could rewrite this as x to the 1/4 power. So what I want you to notice is the numerator and the denominator. So for instance, in here, I had x to the first power. Here, I had x to the first power. And so this inside is my numerator. Oops. And the outside is going to be my denominator. So let's do an example. What if I had, let's see, the third root of x squared? How would I rewrite this as x to some fractional exponent? So I would have x to the 2/3. Because whatever you are, whatever root you're trying to find, third root, fourth root, second root, whatever, that's going to be your denominator. So that's why 3 was my denominator. And the exponent inside is going to be my numerator. All right, so let's try one more. What about if I had the fourth root of x to the 5th? How would I rewrite this? Well, let's see. The 5 would be my numerator, and then the 4 would be my denominator. So that's what I want you to notice here. So I have the second root, all right? It's the square root of x, it's the second root. So secretly there's a 1 as my exponent. So I'll have 1 as my numerator and 2 as my denominator. So square root is the same thing as x to the 1/2 power. All right. So we can go ahead and let's try these out. So write this in radical form. If I have a to the 1/5, this corresponds to the 5th root of a. And keep in mind this is a to the first, because my denominator corresponds to what root I have. All right, pause the video, try b. D to the 7/4. This will correspond to the 4th root of d to the 7th. Yep, so I have the 4 is my denominator, and that's going to be my root. So we can try to write these in exponential form. The 8th root of c. So I know that this is going to be my denominator. So this is the same thing as c to the 1/8. And lastly, part b, I have the 3rd root of c to the -5th. Okay, so the -5 that's inside is my numerator. The 3, whatever root I'm asking for, is going to be my denominator, c to -5/3. The rule up here at the top is talking about when you just have b to the 1/n. So example 1a, this was a to the 1/5. Here, example 2a is c to the 1/8. And then I mixed it up, and b and d, I had a different number on my numerator. So let's talk about these two examples. So 27 to the 1/3 power is the same thing as, well, 1/3 is just the cube root of 27. So what times itself 3 times is 27? That would be 3. 3 times 3 times 3. Awesome. And then this -16 to the 1/2, to the 1/2 is the same thing as the square root. We know square root of -16 is just going to be, well, it's the same thing as square root of 16 times square root of -1, and the square root -1 is going to be I. It's the imaginary number. All right, so this is standing for I. Here, the square root of 16 is plus or minus 4. So, but we didn't ask for the plus or minus, so that's why we just said 4i, because that's the principal root. Okay, so notice these are all the numerators were 1. Now this next key concept is talking about what happens when your numerator is not 1, but we've already dealt with this a little bit. Alright, so let's evaluate 49 to the negative 1/2. This negative, we know from rule of exponents, means we're going to switch to be on the other side of the fraction. So this is the same thing as saying 1 over 49 to the 1/2 power. Also, we know the 1/2 power is the square root. 1 over the square root of 49. We know the square root of 49 is 7, so it's just going to be 1/7. Right, so our rules of exponents, right, keep in mind our rules of exponents, like 2 to the negative 3 is the same thing as 1 over 2 to the 3rd power. We get rid of the negative by flipping to the other side of the fraction. Okay, so another thing we need to talk about besides the rules of exponents are, what if I have like 2 to the 5/3? Another way I could write this, what we have been doing, is the cube root of 2 to the 5th power. We could also say that this is the same thing as cube root of 2 all to the 5th power. We could say this is all to the 5th power. So that's another trick that we're going to use. If I rewrite part B, which is 32 to the 2/5, I have the 5th root of 32 squared. So 32 squared's not going to be, it's not going to be a small number. So instead, what I want to do is I want to take the 5th root of 32, and then I'm going to square the whole thing. Okay, so 32 breaks down into 4 and 8. 4 times 4, okay, so it's 2 times 2. 8 is just 2 and 4. Let's see, 4 is 2 and 2. So since this is the 5th root, right, I'm looking for a group of 5, which is what I have. Here are my group of 5. 2 times 2 times 2 times 2 times 2. Okay, so 2 to the 5th is equal to 32. So the 5th root of 32, the 5th root of 32 is just 2. And then I want to square it, so this is 2 squared is just going to be 4. Awesome. So it's just going to be 4. All right, so let's try one more just like this. Do we have room? Yes, right over here. So make our own part C. So my next example is 81 to the 3/4 power. 81 to the 3/4 power. All right, so this is the same thing as saying the 4th root of 81 all to the 3rd power. So let's see, what times itself 4 times is 81. I know this is 9 times 9. Each 9 is 3. So 3 to the 4th power is 81. So I have 3 to the 3rd. 3 times 3 times 3 is just 27. So I took the inside first, right? I did the 4th root of 81, and then I cubed it. Let's see. Let's just do a little more review about our rules of exponents, and then we'll go on to the next page. What happens if I have a squared, b to the negative 2 over c to negative 3? What does this simplify to? Well, the a is left alone since it has a positive exponent. I'm going to flip my c to the top, so that way it's a c to the 3rd to get rid of the negative. And then I'll have my b to the 2nd on the bottom because I want to get rid of the negative. I want to get rid of the negative in the exponent, so to do that, I flip it on the other side of the fraction. Okay, so we're half done with the lesson. Great job. So now if we want to simplify expressions using all the algebraic operations we've learned, so we have a couple rules we have to think about. So we're not allowed to have improper fractions as exponents, and we're not allowed to have fractions as exponents in the denominator. Okay, so just here's the key of solving these problems. You have to understand that a squared times a cubed is going to be a to the 5th, right? So we're going to do a lot of adding exponents, right? Multiplying exponents together, just moving all of this together. Okay, so I'm going to simplify. So if I'm multiplying bases together, I'm just going to be adding the fraction. I'm just going to be combining the exponent. I'm going to add the fractions together. So I have y to the 1/7 plus 4/7. So this is just y to the 5/7. And we can leave that because this is not an improper fraction, meaning it's less than 1, and it's not in the denominator, right? So this is just y by itself. Okay, let's try b. X to the negative 2/3. Well, I'm going to rewrite that immediately as x to the 2/3. All right, I'm going to get rid of the negative. But now I have an exponent. I have a fraction as an exponent in my denominator. So what I want to happen is I want this just to be x to the first on the bottom. So what do I need to multiply by in order to get the exponent to equal 1? I need to multiply by 1/3 because 2/3 plus 1/3 gives me 1. And when I multiply 2/3 x to the 2/3 times x to the 1/3, I get x to the first. So I have to multiply by x to the 1/3 over x to the 1/3. And this will give me x to the 1/3 over x. So, okay, so that was a little more difficult, but you can do this. All right, so let's check out example C. This is a little rough, but the first thing I want to do is make the bases the same. So I have, can I simplify this at all? So I can simplify the top one as the 6th root of 2 to the 4th because I have a 2 on the bottom. I want to put everything in terms of 2, and I know 16 is just 2 to the 4th power all over cube root of 2. Okay, so I can rewrite this as 2 to the 4th 6th over 2 to the 3rd. This is pure magic. This is awesome. Okay, 2 to the 2/3, just simplify that over 2 to the 3rd. Let's use rules of exponents. So I do the exponent on top, 2/3, subtracting the exponent on bottom, so minus 1/3, gives me 2 to the 1/3 power. I also could write this as, alright, so this is the same thing as the cube root of 2. Alright, so that means the exact same thing. Part D, you can always pause the video, try it. How could I write this and make it a little easier? Anything, you want to make anything that's a square number, square exponent, just rewrite it in the smallest terms. So I'll write this as 2 squared. This is x to the 4th, all over, all to the 6th root. So I can rewrite this as 2 to the 2/6 times x to the 4/6. 2/6 simplifies to 1/3. 4/6 simplifies to 2/3. So this is the same thing as the cube root of 2 times the cube root of x squared. So to fully simplify, I can write the cube root of 2x squared. All right, let's try E. Actually, we're not going to do E, but we could do F, and this will be the last one that we do. So let's just write this all out. Since I'm multiplying, I just multiply them together. Okay, so B to cube C all over C to the 1/2 over B to the 1/3. And one of the rules I talked about was you cannot have fractions as exponents in the denominator. So I'm just going to go term by term. So I have B to the 3 minus 1/3, right? Because it's the top numerators exponent minus the bottom denominators, times C to the 1st minus 1/2. All right, so 3 minus a third. Let's see. 3 minus a third is the same thing as 9/3 minus a third. So I have b to the 8/3. Oh my gosh. b to the 8/3 times c to the 1/2. Oh, now we have an improper fraction. What the heck? I gotta change this. Okay. So, 8/3 is, let's see, 8 divided by 3. 3 times 2 is 6. So it goes evenly 2 times with a remainder of 2. So what this is going to look like is I'm going to have b squared times b to the 2/3 times c to the 1/2. And this is all I can simplify it. So then I'm done. Awesome. So your problems are just 1 through 8. And this is just summarizing the list of rules.